Welcome to Sleepy Scientific Secrets, a quiet corner where we leave the noise of the day behind and gently uncover the hidden wonders of our world. Tonight, we begin a fascinating exploration. The journey drifts far beyond familiar stars toward a place where light feels heavier and silence feels deeper. Scientists have discovered that deep in our galaxy, there is a planet called 55 Cancri E that is believed to be rich in carbon and shaped by extreme heat and pressure. Under those conditions, carbon atoms can lock together into crystal forms much like diamonds. The idea of a world made partly of diamond feels like a slow sparkle floating in the dark. A gentle reminder that even in distant space there are places built from beauty and time. And as you breathe softly, you might imagine that distant world turning quietly in its orbit. And another fascinating aspect is the temperature of this diamond planet. Scientists have discovered that its surface may reach more than 2,000 degrees Celsius, hot enough to melt metal and reshape stone. In that glowing heat, the surface could shine like liquid glass under a distant sun. It is a world where night and day blur into a steady glow. You might picture it as a quiet ember drifting through space, holding its warmth like a memory that never fades. If tonight's exploration felt like a peaceful escape, you can let me know with a like or stay longer by subscribing. Either way, I'm grateful you're here. And if you feel like sharing, I'd love to know. What quiet corner of the world is listening along? What is particularly interesting here is how close this planet is to its star. It completes one full orbit in less than 18 hours. A year there passes in less than a single day on Earth. Time would feel like a soft blur of light and shadow, as if the planet is gently spinning through moments instead of days. You might imagine standing still while seasons rush past like passing clouds. Scientists have also discovered that the gravity on this world is much stronger than on Earth. The planet is about twice as wide and 8 times as heavy. Everything there would feel pressed gently downward, as if the ground itself is holding you in a quiet embrace. Even light would seem to linger a little longer before drifting away. And another fascinating aspect is what may lie beneath its glowing surface. Models suggest vast layers of crystalline carbon and diamond-like rock. Deep inside the planet, pressure turns simple elements into eternal stone, a slow, patient process that takes place over millions of years. Like a silent artist shaping a sculpture you will never touch but can still imagine. And as the planet continues its endless orbit through the dark, it carries these hidden treasures quietly through the galaxy. Building on this idea, the planet reveals another quiet secret. Research shows that 55 Cancri A is tidally locked to its star. One side always faces the light, and the other rests in endless night. The bright side glows like a slow furnace, while the dark side cools into deep shadow. Between them may lie a narrow band where temperatures soften into a gentle balance. You might imagine a thin ribbon of calm circling the world, where heat and darkness meet like two slow tides. Another layer of understanding reveals that this planet is likely covered by vast oceans of molten rock. Scientists believe the surface may be shaped by rivers of lava that move like glowing ink across stone. In this distant place, mountains may rise only to melt and flow again. The land itself is always in motion. A quiet reminder that even solid ground can drift like a dream. Research shows that the atmosphere of this world may be rich in vapor from rock and crystal. Instead of clouds of water, there may be clouds of silicate drifting through the sky. The air could shimmer with tiny fragments of stone carried on warm winds. You might picture a sky that glows faintly like powdered stars, a sky that falls slowly back to the ground as glittering dust. Building on this idea, scientists have studied the light reflected from the planet as it passes in front of its star. Subtle changes in brightness suggest a surface that reflects more light than bare rock. This could be the soft shine of crystal fields spread across wide plains. From far away, the planet may look like a small lantern floating through space, holding a steady glow in the dark. Another layer of understanding reveals how this world may have formed from a cloud rich in carbon rather than oxygen. Most planets, like Earth, are built from silicates and metal. This one may have grown from carbon dust and gas. Over time, gravity pressed those particles together into a dense and shining sphere, a slow gathering of starlight into solid form, as if the galaxy shaped a jewel and set it gently into orbit, drifting through the dark where starlight moves like a slow tide across endless distance. Building on this idea, scientists observe tiny changes in the planet's motion that reveal the pull of its star. The gravity between them stretches the planet slightly into an oval shape. This constant stretching creates friction deep inside the world and adds even more heat to its core. It is like a quiet heartbeat that never rests, warming the planet from within as it travels its glowing path. Another layer of understanding reveals that this intense gravity may also cause powerful volcanic activity. Research shows that tidal forces can crack the crust and allow molten rock to rise again and again. Vast lava lakes may appear and vanish over time, their surfaces cooling into dark glass before melting once more. You might imagine these glowing seas breathing slowly with the rhythm of the planet. Building on this idea, astronomers have measured subtle shifts in the color of light around the planet. These shifts suggest the presence of heavy elements in the atmosphere, such as sodium and calcium vapor. These atoms glow softly when heated by the nearby star, painting the sky with faint tones of gold and pale blue. A sky that looks less like air and more like light itself. A gentle reminder that even distant worlds can carry their own colors. Research shows that the planet is part of a larger family of worlds orbiting the same star. Some are gas giants drifting far away, while others move closer in quiet loops. Together, they form a slow-moving system of light and shadow, each planet tracing its own calm path through space. You might picture them as beads on invisible strings, turning around their star in patient silence. Another layer of understanding reveals that the star itself is slightly smaller and cooler than our sun. Its softer light gives the diamond planet a warm orange glow instead of bright white. This steady amber light wraps the planet in a constant dusk, a world forever resting in the colors of evening, as if the day there never fully ends and never truly begins, where light rests softly on the surface like a long-held breath. Building on this idea, astronomers have studied tiny variations in the planet's brightness as it moves around its star. These variations suggest that the surface may be uneven with vast regions of glowing lava and darker cooled plains. The world may be patterned like a slow-moving mosaic of fire and stone, a quiet, shifting artwork painted by heat and time. Another layer of understanding reveals that this planet is likely losing material into space. Research shows that extreme heat can cause atoms and molecules to escape the atmosphere and drift away like a thin, glowing tail. Traces of vapor may follow the planet along its orbit, a faint ribbon of matter stretching behind it, as if the world leaves a soft signature wherever it goes. Building on this idea, scientists have modeled the interior of the planet using its mass and size. Their studies suggest a dense core rich in iron, surrounded by thick layers of carbon-based rock. Under immense pressure, these layers may form vast regions of diamond-like crystal. Deep inside the planet, the darkness may be filled with silent light trapped inside stone. You might imagine an inner world that never sees the stars yet carries their memory in every crystal. Research shows that because of its close orbit, the planet is constantly bombarded by radiation from its star. This radiation can strip away lighter elements and reshape the atmosphere over time. The sky above the planet is never still, always changing in slow, invisible ways, like a veil that is gently woven and unwoven by starlight. Another layer of understanding reveals that worlds like this were once thought impossible. For many years, scientists believed planets would form only from materials like those that built Earth. The discovery of a carbon-rich planet changed that view. It showed that the galaxy can shape worlds in many quiet and surprising ways, as if space itself enjoys creating variations on a familiar theme, each one drifting patiently through the dark with its own story written in light, and carrying its quiet presence through the wide calm of space. Building on this idea, astronomers have learned that 55 Cancri E reflects light differently as it moves through its orbit. The pattern of reflection suggests that parts of the surface may be smooth like glass, while other regions are rough and fractured. Light touches these places in different ways. Some areas glow softly, while others swallow the brightness into shadow. You might imagine the planet turning slowly as if showing many faces to the distant stars. Another layer of understanding reveals that this world is likely shaped by constant seismic movement. Research shows that strong tidal forces can create planet-wide stress that fractures the crust again and again. The ground may tremble in slow, silent waves. Cracks may open and close over time like breathing stone. It is a planet that never fully rests, always shifting quietly beneath its glowing skin. Building on this idea, scientists compare this world to the volcanic moon Io that circles Jupiter. Io is the most volcanically active body in our solar system. In a similar way, 55 Cancri A may be covered in thousands of glowing vents and molten lakes, fire rising from deep within and spilling across the land. You might picture these fires as distant stars scattered across the surface, each one burning in its own quiet rhythm. Research shows that the star that warms this planet is around 40 light years away from Earth. The light we see today began its journey before many people on Earth were even born. It traveled across dark space for decades before touching our telescopes. When you look toward that star, you are seeing into the past, a gentle reminder that the universe moves on timescales far slower than our own. Another layer of understanding reveals that planets like this help scientists learn how worlds are born and changed. By studying their heat and motion in light, researchers build new models of planetary evolution. Each discovery adds a small piece to a much larger picture. A picture of countless worlds forming and drifting through the galaxy, each one shaped by gravity and time and quiet persistence, and drifting onward through the deep stillness between stars. Building on this idea, astronomers have observed that the planet slowly loses heat into space, despite its intense internal warmth. Over millions of years, this cooling reshapes the balance between its molten surface and solid crust. Some regions may thicken into darker plates, while others remain thin and glowing. The planet becomes a quiet map of heat and memory written in stone. You might imagine those patterns forming slowly like lines in cooling glass. Another layer of understanding reveals that the strong gravity of this world compresses its interior into extreme density. Research shows that pressure deep below the surface may be millions of times greater than on Earth. At those depths, atoms are pressed so tightly that their structures change. Carbon rearranges itself into rigid crystal networks, a hidden architecture built from pure pressure and time, as if the heart of the planet is a silent cathedral of stone. Building on this idea, scientists study how sound might travel through such a dense world. Models suggest that vibrations would move faster and farther through diamond-rich layers than through ordinary rock. A tremor on one side of the planet could echo deep inside for a long time. You might picture the planet listening to itself, feeling every movement like a slow internal song. Research shows that the planet may also experience powerful electrical storms driven by heat and motion in its atmosphere. Charged particles rising from the molten surface could build vast fields of energy. When these fields release their charge, they may create lightning far brighter than any on Earth. Flashes of light racing across a glowing sky. Brief signals from a restless world speaking in light. Another layer of understanding reveals how astronomers first detected this planet by watching its star dim by a tiny amount. Each time the planet passed in front of the star, it blocked a small fraction of the light. From that gentle shadow, scientists learned its size and path, a discovery made not by touch but by patience and careful watching, as if the universe leaves soft footprints for those who learn how to see them. And so the diamond planet continues its endless orbit, turning quietly in warm starlight, carrying its weight of crystal and fire through the calm of space, where distance feels like a soft ocean and every star is a quiet island of light. Building on this idea, astronomers have calculated that the planet is slowly spiraling closer to its star over very long timescales. Gravitational tides gently pull it inward, a fraction at a time. This slow drift may one day change the balance of heat and motion across its surface. A future written not in years, but in millions of silent orbits. You might imagine the planet gliding inward like a leaf carried by an unseen current. Another layer of understanding reveals that the intense heat of the star may cause parts of the surface to vaporize directly into space. Research shows that rock on this world can pass from solid to gas without melting, rising from the ground as glowing vapor before fading into the dark. The surface may slowly breathe itself away, a gentle exchange between stone and sky. Building on this idea, scientists study how the planet reflects infrared light. These measurements reveal how heat is carried from the bright side to the dark side by strong winds high above the surface. Streams of superheated air may flow endlessly around the world, carrying warmth across the boundary between day and night. You might picture these winds as invisible rivers circling a glowing shore. Research shows that the magnetic field of this planet may be shaped by its molten interior. As liquid metal moves deep below the surface, it can generate powerful magnetic forces. These forces stretch far into space and interact with the wind from the star, creating glowing arcs of charged particles around the planet, soft curtains of light drifting through its upper sky, a quiet echo of the auroras seen on Earth. Another layer of understanding reveals that planets like this help scientists refine the search for other exotic worlds. By comparing their mass and heat and composition, researchers learn how different kinds of planets take shape. Each discovery sharpens the picture of how diverse the galaxy truly is. A slow, unfolding map of countless possibilities. And so the diamond planet continues its endless turning, wrapped in warm starlight and deep shadow, moving patiently through the wide calm of the Milky Way, and carrying with it the slow memory of heat and crystal across oceans of darkness. Building on this idea, astronomers have estimated the mass of the planet with remarkable precision by measuring how strongly it pulls on its star. The tiny wobble of the star reveals the weight of the world that circles it. From that motion, scientists know the planet is far denser than Earth, a compact sphere where matter is pressed into a smaller, quieter shape. You might imagine its gravity holding every grain of crystal in a careful embrace. Another layer of understanding reveals that the planet reflects different colors of light depending on the angle of its orbit. Research shows that when its glowing side faces Earth, the reflected light carries a warmer tone. When its darker regions turn toward us, the light grows softer and dimmer. The planet slowly changes its face like a lantern turning in gentle hands, a distant signal that time is passing far away. Building on this idea, scientists examine how the planet absorbs energy from its star. Models suggest that much of this energy sinks deep into the interior rather than remaining only at the surface. Heat flows downward through layers of rock and crystal, feeding the molten heart below. You might picture warmth drifting slowly inward like sunlight sinking into deep water. Research shows that the planet formed in a region of space rich in carbon dust left behind by older stars. These ancient stars ended their lives by releasing clouds of material into space. Over time, gravity gathered that material into new worlds. The diamond planet carries the legacy of those long-vanished suns, a quiet inheritance written in crystal and stone. Another layer of understanding reveals that worlds like this help scientists trace the history of our galaxy. By studying their composition, researchers learn where different elements were born and how they spread through space. Each planet becomes a small archive of cosmic time, a drifting record of ancient stars and forgotten explosions. And so the diamond planet continues its patient journey, turning beneath a warm, distant sun, holding within it the deep memory of the Milky Way, and drifting onward through the gentle architecture of spiral arms. Building on this idea, astronomers track how the planet's orbit is slightly tilted relative to the star's equatorial plane. This tilt changes how starlight strikes its surface over long cycles. Some regions receive more warmth for a time, while others rest in softer shadow. The planet slowly adjusts like a turning gem, catching different angles of light. You might imagine its glow shifting as quietly as a candle in a calm room. Another layer of understanding reveals that the planet likely experiences powerful atmospheric tides. Research shows that the pull of the star can raise waves of heated gas that move around the world. These tides transport energy and shape weather patterns high above the molten ground. The sky itself becomes a moving ocean of warm currents, a ceiling of flowing air that never fully settles. Building on this idea, scientists analyze the spectrum of light passing through the planet's atmosphere during transit. In that thin filter, they search for signatures of carbon monoxide and other heavy molecules. Their presence would reveal how heat breaks down rock and rebuilds it as vapor. The atmosphere becomes a mirror of the surface below, a quiet exchange between stone and sky. Research shows that over very long periods, the planet may shed enough material to slowly shrink in size. Each lost atom drifts away into interstellar space and becomes part of a wider cloud. In time, that cloud may help form new stars and new worlds. The planet gives a little of itself back to the galaxy, a slow and gentle return. Another layer of understanding reveals that the star and its planets move together around the center of the Milky Way. They complete one vast orbit every few 100 million years. During that journey, they pass through regions of dust and light and open space. The diamond planet travels this long road without changing its steady rhythm, turning quietly as the galaxy turns around it, carrying its inner fire through the endless night, carrying its inner fire through the endless night. Building on this idea, astronomers have refined measurements of the planet's radius using repeated transits across its star. Each transit traces a thin shadow that reveals the curve of the world's edge. From these shadows, scientists map its shape with gentle precision, a distant outline drawn in starlight. You might imagine the planet sketched again and again on the dark page of space. Another layer of understanding reveals that the planet spins at nearly the same pace as its orbit. Research shows that one rotation matches its short year. This keeps the same face turned toward the star and holds the boundary between day and night in a steady place. The world turns without changing its view, a quiet balance between motion and stillness. Building on this idea, scientists explore how minerals behave under the planet's extreme temperatures. Experiments on Earth show that carbon-rich rocks can soften and flow like thick liquid when heated beyond a certain point. On this world, those conditions are everywhere. The surface may ripple slowly like a dark sea. You might picture waves of glowing stone rolling in long, unhurried lines. Research shows that the planet emits strong infrared radiation as it releases heat into space. Telescopes tuned to these wavelengths detect its warm signature against the cold background of the galaxy. In that invisible glow, astronomers read the language of temperature and motion, a message sent across 40 light years, a reminder that even in silence, worlds speak. Another layer of understanding reveals that the system around this star is remarkably stable. The planets have kept their paths for billions of years. Their orbits remain calm and predictable. This stability allows the diamond planet to endure its slow changes without sudden disruption. It continues its turning as it always has, held in place by gravity and time. Building on this idea, researchers compare this world with other carbon-rich candidates found farther away. Some may share similar interiors and glowing surfaces. Together, they form a small family of rare planets shaped by unusual chemistry. A quiet collection scattered across the Milky Way, each one carrying a different expression of the same ancient elements. Another layer of understanding reveals that the light from this system passes through clouds of interstellar dust before reaching Earth. Along the way, some colors are softened and others fade. By the time the light arrives, it carries the memory of its long journey. You might imagine it as a traveler arriving gently at our instruments after decades in the dark. And so the diamond planet continues its steady path, turning beneath a warm, distant star. Shaped by pressure and fire and patient gravity, drifting through the vast calm where galaxies slowly breathe and every world keeps its own quiet rhythm. Drifting through the calm currents of the galaxy and carrying the quiet memory of ancient fires within. Building on this idea, astronomers have measured tiny fluctuations in the planet's orbit caused by other unseen bodies in the system. These subtle tugs suggest that neighboring planets exert gentle gravitational influence. The planet moves with a slow choreography, like dancers circling each other in invisible space. You might imagine it following an unspoken rhythm set by distant companions. Another layer of understanding reveals that the intense heat from the star may melt surface rock into short-lived rivers of lava. Research shows that these flows can travel hundreds of kilometers across the planet's face before cooling into jagged, crystalline plains. Streams of fire frozen mid-motion. A slow painting of light and shadow that shifts imperceptibly over time. You might picture them as glowing veins beneath a soft, dark canopy. Building on this idea, scientists study the spectrum of thermal radiation emitted from the planet. Measurements reveal variations in surface temperature that hint at active geological processes. Some regions are hotter and more restless, while others are cooler and settled. The planet exhales its heat into space like a living organism with a slow, patient pulse. You might imagine its warmth radiating outward, unnoticed but persistent. Research shows that high-energy particles from the star can interact with the planet's upper layers, creating thin, ionized regions. These charged particles move along magnetic field lines, generating subtle currents that ripple invisibly through the sky. A quiet, almost secret movement that never reaches our eyes but can be traced by careful instruments. A gentle reminder of unseen activity above the glowing surface. Another layer of understanding reveals that the diamonds deep within the planet's core are formed under pressure millions of times greater than anything on Earth. Carbon atoms are pressed into rigid lattices, creating a hidden architecture that endures heat and movement. A silent cathedral of crystal that supports the restless surface above. You might imagine this interior as a quiet sanctuary, glowing faintly in the darkness and holding the memory of every turn and tremor above. Building on this idea, scientists compare these conditions with those found in other exotic worlds, noting how variations in mass, composition, and stellar heat can produce entirely different outcomes. Each planet becomes a unique experiment in cosmic creativity. You might picture the galaxy as a vast artist's studio where worlds form and drift in patient silence, each one carrying its own story of light, fire, and stone. And so the diamond planet continues its orbit, turning beneath a distant sun, wrapped in warmth and shadow, holding its molten and crystalline heart close while drifting silently through the dark expanse of the Milky Way. Wrapped in warmth and shadow, holding its molten and crystalline heart close while drifting silently through the dark expanse of the Milky Way. Building on this idea, astronomers have observed that the planet's surface may be covered in shifting layers of diamond dust carried by high-altitude winds. Research shows that these particles can circulate continuously around the globe, catching the distant starlight and scattering it softly across the sky. You might imagine a gentle snowfall of crystal floating in invisible currents, each tiny fragment glinting as it moves. Another layer of understanding reveals that tidal forces between the planet and its star generate internal friction that keeps the interior molten. This heat circulates slowly through layers of carbon and rock, creating convection currents that sustain the deep core. The planet hums quietly from within, a resonance so slow it might pass unnoticed over centuries. You might picture it as a heartbeat beneath the luminous crust, steady and enduring. Building on this idea, scientists have modeled how reflective surfaces on the planet affect its temperature balance. Bright, crystalline planes send heat back toward space, while darker regions absorb energy and slowly release it over time. This gentle interplay of light and shadow smooths extremes and allows the planet to maintain a subtle rhythm of warmth. You might imagine the surface breathing in light and exhaling calm across endless nights and days. Research shows that the planet's orbit interacts with interstellar gas clouds as it drifts through the galaxy. These encounters are rare but can slightly perturb the trajectory, nudging the planet gently without altering its steady course. Each passage leaves a whisper of motion that accumulates over millions of years. You might picture the planet gliding like a silent boat over a cosmic sea, its path guided by invisible tides. Another layer of understanding reveals that elements formed in ancient supernovae are embedded within the planet's interior. Iron, carbon, and trace heavy metals mingle under immense pressure to create the hidden architecture of the world. Each atom carries the story of distant stars long extinguished, preserved in silence beneath layers of crystal and molten stone. You might imagine these elements as tiny libraries of cosmic history, quietly waiting while the diamond planet turns, drifts, and glows beneath a distant, unwavering sun. And so we continue to drift with the diamond planet through the endless quiet of space. Its light glimmers softly against the distant stars. The gentle movements of molten rock and crystal beneath its surface echo like whispers. Invisible winds carry diamond dust across its surface with a slow, patient rhythm. Tides and currents hum quietly in the hidden interior. The warmth of its core radiates outward, steady and calm. Light and shadow play softly across crystalline plains. The planet glides along its orbit, unhurried and serene. Every atom within holds the memory of distant stars. The quiet persistence of motion soothes the vast darkness around it. We linger in the calm, feeling the slow cadence of its journey. The galaxy stretches infinitely, yet here there is a gentle presence. Our thoughts begin to soften as we follow its quiet path. Each moment passes slowly, like soft breath in the night. The distant light warms the imagination in subtle waves. Drifting deeper into stillness, the world moves without hurry. The whisper of time passes around us and within. Calmness settles gently like a soft blanket. The motions become smaller, lighter, almost imperceptible. And as we watch, everything grows quiet. The world turns slowly beneath its distant sun. And now we rest in its gentle light.